Right, and talking about squares and cubes, there are things called perfect squares and perfect cubes. So the first thing it tells us is that the number 9 is a perfect square. And it asks us to find 4 numbers that are perfect squares and 2 numbers that are not perfect squares. So a perfect square, right, if I understand a square, right, I'm going to draw one. And let's say if I know that the number 9 is a perfect square, 3 times 3, right, gives me 9. So it's basically asking us numbers multiplied by themselves are perfect squares. So I could do 2 times 2, which equals 4. So 4 is a perfect square. Then I can do 4 times 4. 16 is a perfect square. 5 times 5. 25 is a perfect square, because we're basically talking about if the measurements are the same in a square, right? So like 5 times 5 is asking us what the perfect square would be: 4, 16, 25. And you can revert back, so I can take the square root of this and find that the square root of 25 should be 5, because it should be the side length of a square. And ask us to find numbers that are not perfect squares. So if I take any, like, so if I'm trying to find the area of a rectangle, right, if I have 4 and 2, 4 times 2 gives me 8. 8 is not a perfect square, because if I did the square root of 8, square root meaning that it looks like this, then it would give me, it would not give me a perfect square, because both of these numbers should be the same. And then, let's see, another number would be 3 times 2 equals 6. 6 is also not a perfect square. So those are 2 examples of that. Down here it says the number 27 is a perfect cube. Cube meaning that all the sides are the same. Asks us to find 4 other numbers that are not perfect cubes. So for a cube, when we cube something, we're multiplying it by itself 3 times. So to get 27, we have to understand that 3 times 3 times 3. And when I write that out like that, 3 times 3 is 9, times 3 gives me that 27. So that means that each side of the cube was 3 units, right? And that's finding the volume of something. So if I want to do something, if I want to find other ones, then I multiply other numbers by itself 3 times. 4 times 4 is 16, times 4 is 64. So 64 is another perfect example. Let's see, 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. 125 is a perfect example. We could do 2. 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Right? 8 is a perfect cube. And then, let's see, there's kind of 4 examples there. And things that are not perfect cubes would be any number that's not multiplied by itself 3 times, like 2 times 3 times 3. 2 times 3 would be 6, times 3 is 18. That's not a perfect cube because not all the sides are the same. So this one says a cube has a side length of 4 centimeters. What is its volume? So if it tells me that a cube's side length is 4, that means I'm going to multiply it by, multiply this number by itself 3 times. So 4 times 4 times 4. 4 times 4 is 16, times 4 is 64 centimeters cubed. Right, so now we're adding that unit. This one says a cube has a side length of 10 inches. What is its volume? So if it tells me that it's 10.
I was very glad to not see you this morning at 6:15 because I figured things were calmer. I missed that you weren't in the building, but I figured you weren't panicked if you weren't here at the crack of dawn.
True.
So I thought,
Ted.
I was thankful that things were calmer.
Yeah.
So, just wanted you to know I missed you, but I was glad that you didn't have to be.
10 times 10. So I apologize for the interruption, but so a cube has a side length of 10 inches. What is its volume? 10 times 10 times 10. So remember, we're multiplying the number by itself 3 times. 100 times 10 would give us 1,000 inches cubed, right? It says a square has a side length of 7 kilometers. What's its area? So a square has a side length of 7 kilometers. What is its area? Area is 2-dimensional, so I'm going to take, and it's a square, so I know that both sides are 7. So 7 times 7 gives us 49 kilometers squared. The area of a square is 64 square centimeters. What is its side length? So for this example, what we're going to do is we're going to understand that this is the area, right? So I know that if we go back to this understanding, 64 equals base times height, right? So I'm asking what number times itself is going to give me 64. Another way of looking at that is taking the square root of 64, which is asking what number times itself gives me 64. Well, 8 times itself will give me 64 because 64 is a perfect square. That means both sides of it are 8. So really this is 8 centimeters. Then down here it says a cube has a side length s units. What is its volume? So to find volume, if they're all s, it should be s times s times s, right? That equals volume. So for this one, since they're all alike, what I'm going to write is I'm going to write s to the third power cubic units, because that simplifies that. And so s to the third power cubic units would represent those times itself 3 times. So this is the long way of writing it. This is the shorthand writing of it. So long, short. On the back, we're talking about introducing exponents. So it says a square has a side length of 10. Use an exponent to express its area. Well, I know if a square has a side length of 10, an exponent is something raised to a power, and so basically the exponent is I'm going to multiply 10 by itself. So 10 times 10 to find the area because the square is 2-dimensional. So I'm going to multiply side by side, which would be 10 to the second power centimeters squared. And an exponent is just, something raised to a power. The area of a square is 7 squared square inches. What is its side length? So understand that 7 squared, this is a shorthand version. If I want to know what that means 7 times 7. So if I want to understand, right, if I want to understand how this is represented, I understand that one of its side lengths would be 7. So 7 square inches. The area of a square is 81 meters squared. Use an exponent to express its area. So if the area is 81, I'm really looking for the square root or some number times itself, right? So it should be side times side. So a number times itself that gives me 81. Well, I know 9 times 9 gives me 81. So I need to write 9 squared meters squared would be, use an exponent to express this area. 9 squared would give me the 81 that I need. It says a cube has an edge length of 5 inches. Use an exponent to express its volume. So remember, volume equals side times side times side. So if I have 5, that means 5 times 5 times 5. Written in the shorthand version, that would be 5 to the third power, or 5 cubed. And then I need to write inches cubed. The volume of a cube is 6 to the third power centimeters cubed. What is its edge length? That means I need to do 6 times 6 times 6 is the same thing as 6 cubed. So an edge length would be one of these. One of these is 6 centimeters. Because I'm just looking at one of them. This says cube has edge length s units. Use an exponent to write an expression for its volume. Well, no, volume equals s times s times s. To write that as an exponent, this is the longhand version, so s to the third power cubic units. All right, and then over here it says we're going to find some numbers that are both perfect squares and perfect cubes. So it gives us an example, 1 squared. So if I write 1 times 1, that gives me 1. And then 1 times 1 times 1 would give me 1 as well. So both of those equal the same thing. So it's asking us what are some numbers that are also perfect squares? One example, perfect squares and perfect cubes. If I did 0 times 0, that'd give me 0. If I did 0 times 0 times 0, that would also give me 0. So what are some other possibilities there? For squaring a number, when we square a number, we multiply a number by itself. And when we cube a number, we multiply a number by itself 3 times. So this example would be like 2 times 2. That would be squaring a number. This would be 2 times 2 times 2. That would be called cubing a number. An exponent, friends, an exponent is, some people would say it's that small little number that you see, but it actually has a meaning that we need to know and understand. So an exponent, give me a second, exponent, because I want to make sure that we get the best definition, is a quantity representing the power to which a given number or expression is to be raised or multiplied by itself. Okay, so that is for this lesson.